Okay, so in this video we're going to be answering our fourth exam style question focusing on differentiation, and this video in particular is going to be looking at the product rule, and below is the question that we're going to be answering in this video. So we need to differentiate e to the 4x tan 2x for 3 marks. And before I actually differentiate the expression, I'm just going to write it in terms of y. And all I'm going to do for that is just say y equals e to the 4x tan 2x. Right, now what we need to do is actually figure out how we're going to differentiate this expression. And there's two things that we can note from the expression that we have in this question. And the first thing is that we have two functions. And what I mean by that is one of these functions is e to the 4x, and the second function is tan 2x. And the second thing we can note is that these two functions are actually multiplied by each other. So the functions are multiplied by each other. And actually, the thing is, both these factors mean that we can use the product rule to differentiate this particular expression. So we can use the product rule. And the product rule is actually this expression here. And the formula for that is dy by dx is equal to f prime x times gx plus fx times g prime x. And you can see here even that you have two functions. So you've got an fx and then gx. And what we're going to do is actually apply that to our question to define two functions. So for argument's sake, I'm going to say, to be consistent with the formula, let's say fx is e to the 4x. And therefore, our gx is going to be the second function, which is tan 2x. So that'll be tan 2x. And actually, you can see from the formula that we're going to actually have to find the differentiation of both functions. So we're going to have to do f prime x and g prime x. Now, what we could do is actually just do this whilst we're solving and differentiating the expression, or we could just do it first. And I think the best thing to actually do is just actually get out of the way first. And that's what I'm going to do here. So first of all, fx, so that's going to be f prime x, and basically we need to differentiate e to the 4x. And the way we do that is, you see this here, 4x is to the power, and we're basically going to differentiate that. And we're going to bring it down. So that's just going to be 4. And the rest will stay exactly the same. So that's just e to the 4x. And likewise, we're going to do the differentiation of tan 2x. And very similarly, we're going to first differentiate this 2x. That's just going to be the number 2. And tan actually means sec squared when we actually differentiate. And then the rest will stay the same, so we'll just have 2x. And now that we've done that, we can easily just differentiate this expression. So we're going to say, therefore, dy by dx. So let's just use a formula. So we've got first f prime x which is now we know is 4e to the 4x. We're just going to bring it from here. We're going to times it by gx, which is this here. So that'll be tan 2x. I'm going to add that to just fx, which is this one here. That's e to the 4x. And then finally we're just going to times it by g prime x, which we have also found this one here. That'll be 2 sec squared 2x. Now you could leave the answer there, but I think the best thing to do is always see if you can actually factorize the expression. And in this case we actually can, because if you look very carefully, this here is e to the 4x, and you can see it's actually common to both parts of the expression. And what we're going to do is actually just factorize that out. So it's going to say therefore dy by dx, if we bring that outside, that's e to the 4x, that's 4 tan 2x. Just being very careful here. And then we've got 2 sec squared 2x. 2 sec squared 2x. And therefore, that is how you can actually end up with the final answer. So that is actually 3 marks. And like I said already, you could just leave the answer there. But I think it's always best practice if you can find a way to actually factorize your final expression. So that's how you can actually differentiate this expression using the product rule, and I hope that was actually helpful.